It's Hwk22 question 4, and this is part A. And for part A, we're after finding to the nearest degree the bearing on which Q is moving, and we're told that Q moves at a velocity of 3I plus 4J, and that's kilometers per hour. Now, what the question also tells us is that I is the movement east, J is the movement north, and we want to find out the bearing that Q is moving. So imagine this is like a triangle. It's moving 3 east, 4 north. And of course, you think of bearings from the GCSE days, it's always starting north. So effectively what we're after is this degree here. That's what we're after, but of course if we use Hwk22 to get this one, we can work out what this chap is here. So in order to get this one, we got an opposite and an adjacent, so also we're going to use tan to the minus 1 at 4 over 3. Put that into calculator, and that'll tell us that's 53.1 degrees. So we know this is 53.1, and of course we're after the bearing in which it's travelling. So we want to find out what this angle is here. We know this is going to be a right angle, so in order to find that, we're just going to do 90 take away 53.1. That will give us 36.9, and of course the question wants it to the nearest degree, so our final answer there is 37 degrees. Another way that you possibly could have done it is focused on this angle here, and you've done the same thing. You've done tan opposite over adjacent. Tan to minus 1 of 304 will also give you 37 degrees as well. Okay, so question 4, part B. I'm going to do parts 1 and 2 for now, and then I'll do part 3 in a separate video later on. What we need to find out is in part 1, we need to find out, write down expressions in terms of t for p. So what we want to find out is a range of expressions that will represent our position of p. Now we're told that at 2 PM p is at I plus j kilometers. So that's its like original position, and we know here that p moves at 2I minus 3j kilometers per hour. So every single hour is going to move 2I minus 3j. So imagine you're moving t hours, you can have t lots of your speed there. So what we need to do is p will equal the original position, which was I plus j, and then of course what we're doing then is started at I plus j, and then for every hour it's going to move 2I minus 3j. Now you've got t hours there, so all you can do here is put t and 2I minus 3j, and that's your final answer for part 1. Part 2 is going to follow very similar. We're looking at Q. Q is at Q kilometers. We want to find out where that could be. At 2 PM it starts at minus 2j. So again, you put minus 2j there. And of course it moves at 3I plus 4j every single hour. For each hour it's moving 3I plus 4j. So if you've got t hours, you can have t and 3I plus 4j. That's your final answer there. Okay, so part 3 and the question 4. Now previously we've done part 1 and 2 of part B, and we got those for P and Q. Now what they're after here is they're after an expression for P to Q. Now in order to do this, that'll just mean Q minus P. So that'll tell you like the distance travelled between two. So what we're effectively going to do is we're going to take away these from each other. So we have a look here. We can have minus 2j minus I plus j. So of course that's going to give us an overruling. If I write it down actually, just to make it look a bit more simple, that will be minus 2j minus I plus j, like that. And then of course we got to also compare expressions with t as well. 3i minus 3i plus 4j minus 2i minus 3j. It's probably extensive working out like that, but I just want to see, make you see where this is heading. So we got minus 2j, and then we're minusing I plus j, so of course that's just going to give us minus I, minus 2j minus positive j will give us minus 3j. And then of course we got this expression for t then. So what we got is 3i minus 2i, which will just give us 1i. Then we've got 4j minus 3j, which will give us 7j. So obviously always keep the i's and the j's together, do not mix them up.